As data architects, we're often told to build these strong, stable structures for our data. But what do you do when the ground underneath you is basically an earthquake zone? Today, we're going to tear down and rebuild an architecture that's designed not just for stability, but for constant, messy, chaotic change. This is how we start building for what's coming next.
Speaking from experience, I've seen this happen over and over again. We build these absolutely beautiful, perfectly structured dimensional models. And you know what? For a little while, they work great. But the second the business changes direction or a new data source gets plugged in, they just start to fall apart.
So why do they break so easily? Well, because today's data world is just in constant motion. Source systems change on a whim, which makes our ETL pipelines incredibly brittle. We're trying to stitch together data from a dozen different places, all overlapping. And then you throw in strict regulations and business rules that seem to change every quarter, and suddenly our beautiful models need constant, painful, and really expensive surgery just to stay alive. Okay, so how do we architect for this chaos? Well, first we'll dig a little deeper into the problem. Then I'll introduce you to the Data Vault model as a real solution. We're going to break it down into its 3 core pieces, see how it stacks up against the models you already know, and, most importantly, figure out exactly when you should and shouldn't use it. All right, let's get into it. This brings us to the Data Vault, and I want you to think of this as more than just another way to model data. It's really a whole new foundation, one that's specifically engineered to not just survive, but actually thrive on complexity and change. At its heart, the really big idea here is something called strategic decoupling. The Data Vault very cleverly separates the things that don't change, like a customer ID or a product number, from all the descriptive stuff that changes all the time, like an address or a price. And that simple separation, well, that's the secret sauce to its incredible resilience. And this leads to a pretty major shift in how we think about data. We're so used to building a single version of the truth, right? That usually means we clean, we transform, and sometimes we even throw away data that doesn't fit our perfect little box. A Data Vault is different. It aims for a single version of the facts. It captures everything, exactly as it came from the source system, the good, the bad, all of it, giving us this perfect auditable history of what we were told and exactly when we were told it. Okay, so how in the world does it actually pull this off? Well, it all boils down to 3 really simple but incredibly powerful building blocks. First up, we have hubs. The easiest way to think about these is as the nouns of your business. They are the anchor for the whole model. They store one thing and one thing only: the unique, stable business keys, your customer IDs, your product SKUs, your employee numbers. Nothing else. This makes them rock solid, and they become the structural backbone of the entire data warehouse. Next, we've got links. If hubs are the nouns, links are the verbs. A link is what connects 2 or more hubs together, capturing some kind of relationship or transaction. So when a customer buys a product, that's a link. What's absolutely critical here is that the link only records the relationship itself. There's no complex business logic in there, which keeps the model clean and flexible. And finally, we have satellites. These are the adjectives. Satellites are what attach to the hubs and links, and they store all the descriptive details that are probably going to change over time: a customer's address, an order's shipping status, a product's price. Every time a value changes in the source system, the satellite just gets a new row with a timestamp. Nothing is ever overwritten, and that gives you a perfect audit trail of every single change, forever. So let's make this real with a super simple e-commerce example. You'd have a customer hub and a product hub. The transaction that connects them, that's your order link. Then you start hanging satellites off of them to store the details. A satellite on the customer hub for the address, another one on the product hub for the description, and maybe a third one on the order link to track its status as it changes. See? Each of these pieces can be loaded and updated all by itself. Now, this whole modular design gets applied across a few distinct layers. Raw data comes into a staging area first, then it gets loaded into what we call the raw vault. That's our pure auditable layer of hubs, links, and satellites. On top of that, we can build a business vault, which is where we apply all our business rules. And then finally, from there, we create our denormalized data marts, things like star schemas, for really fast, high-performance analytics and BI tools. So, where does Data Vault actually fit into the bigger picture of data modeling? Well, to really get it, you have to understand the classic problem every single architect faces: that constant tug of war between flexibility and simplicity. For decades, we've lived with this fundamental trade-off.
On one hand, you have normalization. This gives us fantastic data integrity by breaking data into lots of small tables, which is perfect for transactional systems. On the other hand, you have denormalization. This gives us blazing fast query speeds by creating these big, wide tables, which is great for analysis but can become an inconsistent mess as things get bigger. You basically had to pick a side. And this is where Data Vault just plays a different game. Look at that high score for source flexibility and the built-in audit trail. It pulls this off with a really clever hybrid approach. Its core, the raw vault, is highly normalized, which gives you maximum integrity and saves on storage. But for reporting, it feeds simple, denormalized star schemas out to the presentation layer. You get the best of both worlds, a rock-solid auditable foundation that can also power lightning-fast, simple analytics. It doesn't force you to choose. Okay, so this all sounds pretty amazing, but let's be real, it is not a silver bullet. This is a powerful architecture, but it's not for every single situation. And knowing when to use it is probably the most important part of getting a project right. It really truly shines in complex enterprise-level environments. If you are integrating data from dozens of source systems that are always changing, you should be looking at Data Vault. If you're in a regulated industry like finance or healthcare that needs a perfect audit trail, Data Vault is your answer. Its modular design is also a huge advantage for large teams because they can all work in parallel without tripping over each other. But, and this is a big but, all that flexibility comes with some overhead. If you've only got a single, stable source system and your reporting needs are pretty straightforward, the complexity of a data vault can actually slow you down. For smaller teams or projects where getting results out the door fast is everything, a traditional star schema is often way quicker to build and easier to maintain. At the end of the day, this is the key takeaway. A data vault provides a foundation that lets your architecture evolve. When a new source system shows up, you just add new hubs, new links, or new satellites. You don't have to go back and re-engineer the entire core of your warehouse. And that's the difference between an architecture that can adapt and one that needs a full system reboot every time the business changes its mind. So that leaves one final question, and it's one I want you to take back to your own team. Take a hard look at your data landscape and ask yourselves, is our architecture built for stability or is it built for evolution? Is it designed for the business we have today or the one we're going to have tomorrow?